Hello everyone, thank you for attending this virtual lab tour. My name is Siu Li. I'm a graduate student in the HST MEM program. We are now in the Bouma lab in the Wellman Center for Photomedicine at Massachusetts General Hospital, which is the Charles River away from MIT. So the Wellman Center for Photomedicine focuses on the development of diagnostic and therapeutic tools by optical interrogation and optical intervention. We study the light and cell and tissue interactions in order to improve health and medical science.
This is our main optic lab. Our lab focuses primarily on optical imaging technique development in clinical translation such as optical coherence tomography, optical endoscopy, and optical microscopy. We have compact OCT systems in transportable carts with morphological and functional imaging capabilities for subsurface, reflectivity, depolarization, birefringence, or optic-axis imaging for high-speed, sensitive, and minimally invasive biomedical applications here, for example, in cardiology, where we can see the optic axis of human coronary artery wall using intravascular OCT, and also in dermatology, where we can render polarization sensitivity to visualize burnt tissue at different depths, and in neurology, where we have label-free imaging of intact neuron brain with OCT that can visualize neural fiber tracts. Also in ophthalmology, where we can visualize optical properties of the retina. And finally, in gastroenterology, we can do OCT imaging of esophagus that can visualize real-time laser thermal ablation of lesion. And we do all this with close collaborations with physicians at Mass General Hospital. Okay, so here we show an OCT imaging example, and we're borrowing Taylor's finger for this imaging demo. So this is an OCT imaging catheter, the imaging probe, and you can see that the laser is spinning and also scanning across the sample. So if we now put our finger on top of the catheter, we now have the cross-section view of the fingertip with a certain penetration depth. We can see the stratum corneum of the epidermis layer with sweat duct, the stratum granulosum, stratum spinsum, and stratum basale. Further beneath is the papillary of dermis layer composed of collagen, elastic fiber, and blood capillaries. This shows the real-time high-resolution subsurface OCT imaging capability. We also have compact fabrication and assembling room and are able to develop spinning catheter endoscopes with motors and polished microbalance for intravascular diagnostic applications such as coronary artery plaque classifications and collaborate with cardiologists for extensive clinical studies.
Hello, this is Siu. I did my master in optoelectronics and bachelor in EE at National Taiwan University. My research interest is in computational optical imaging, where I use computational reconstruction to circumvent hardware limitations. My goal is to develop a healthy and three-dimensional imaging probe with subcellular resolution that may enable label-free endoscopy applications with minimal invasiveness.
Hi, I'm Taylor. I'm a current fourth-year student in the MEM program and in the electrical engineering concentration and a member of the Bouma lab. I did my undergraduate studies at Vanderbilt University, where I majored in biomedical engineering, and I became interested there in optical imaging. And my current projects focus on developing new light-based technologies and signal processing methods for mapping tissue microstructure details in vivo.
Hi, my name is Georgia Thomas, and I'm a first-year MEM student working in the Bouma lab. Before coming here, I did my BSc in physics at McMaster University, and I currently work on projects surrounding the potential applications and technological advancements in intravascular PSOCT.
I think that is a quick taste of what our lab looks like and what the research is primarily about. I hope you enjoyed the video. You can also Google for our official website, Center for Biomedical OCT Research, for more details. Please also feel free to reach out to us, and we welcome you at the HST program. Thank you very much.